For this circuit we need to find the power generated or dissipated, whatever, by each of the sources. So this is a voltage source, this is a current source, and this is a current dependent current source. There are three of them, two independent and one dependent source. So we have to apply node voltage method to solve this problem. So this will be an example of application of node voltage method with the presence of dependent source. So we can see that there is a node here and there is another node here, and this one can be thought of as reference node. So we will write our node voltage equations with respect to this node. So let's call this node, the voltage of this node, to be V1, and let's call the voltage, if this is node 1 the voltage is V1, and if this is node 2 the voltage is V2. So then we will try to write KCL for each of the nodes. So first let's write for node 1, and we can see that instead of using I1, which is an entering current, let's write all the currents as living currents, and instead of I1 we will just write in terms of V1 for this branch. So that will be V1 minus 50 divided by 6. Then this current will be V1 divided by 8, because this is V1 minus 0, this is ground. Then this one will be the current that goes in that direction will be V1 minus V2 over 2, because this one's potential is V2. V1 minus V2 over 2 will be the current going in that direction from the left to the right. And we can see that 3I1, the dependent source current, is entering in this node, so we will write it on the other side. So we will do 3I1. So let's multiply both sides by 24. So we get 4 V1 minus 50 plus 3 V1 plus 12 V1 minus 12 V2 equals to, this will be 72 I1. So once we rationalize, it becomes once we get rid of the brackets basically. So this is 200, and then 3 V1 plus 12 V1 minus 12 V2 equals to 72 I1. So summing up the like terms, we will get 19 V1 minus 12 V2 equals to 72 I1 plus 200. So this is our equation 1. Let's leave it like that. Then we will write KCL for this node. That will be, the downward current will be V2 over 4, downwards current, and then current from node 2 to node 1. If we write now, like, because we are trying to write all the currents as living currents, so that's what we do, unless there is an entering current by a current source, that we have to write accordingly. So this will be V2 minus V1, just the opposite of the previous node, V2 minus V1 over 2, and then I will write the entering current on the right hand side, which is 5 amps, that is 5, and then of course this current, the dependent source current, is also living current, but let's also write that on the other hand side. So that becomes, now it becomes negative because we are writing it on the right hand side, so 3I1. Now we multiply both sides by 4, so it becomes V2 plus 2V2 minus 2V1, and then 20 minus 12I1, or we can say minus 2V1 plus 3V2 equals to minus 12I1 plus 20. So this is our equation 2. So we can multiply, we can do this thing, 1 plus 2 multiplied by 4, I guess. So we are trying to cancel V2, so that's becoming 19 V1 minus 12 V2, this is equation 1, equals to 72 I1 plus 200, 72 I1 plus 200, and this one when multiplied by 4 becomes minus 8v1 plus 12v2, and here it becomes minus 48i1 plus 80. So when we add them, this is getting cancelled, this is getting 11v1 becoming, and this is 24i1 plus 280. Now I haven't talked about it earlier, but there are two simultaneous equations, and it may seem that there are three variables, but actually not, because I1 can be written in terms of V1. So basically two unknowns are V1 and V2. I1 is not an independent unknown because it can be written in terms of V1, and that's what we will do now. So we will write, so 11v1 there equals to 24. Now I1 will be in terms of V1 because, watch it carefully, the current is going I1 in that direction. That means 50 minus V1 over 6 will be I1. 50 minus V1, not V1 minus 50. 50 minus V1 over 6 will be I1, and then plus 280. So this is becoming 11v1 equals to 4. So 200 minus 4v1 plus 280. So that's becoming 15v1 equals to 480, which gives v1 equals to 480 divided by, sorry, this is 15, not 115. Sorry, yep, 15, yep. So this is becoming like that, and this is 32 volts. Once we know V1, we can know also I1, and that will be I1 equals to 50 minus V1, which is 32 over 6, so that is 3 amps. So since we know this, we can talk about now, let's find V2 as well, and then we have every unknown. So V2 will be, if we write from this equation, maybe 3v2 equals to 2v1. So that's 3v2 is equal to 2v1 minus 12i1 plus 20, if I didn't, yes. So that's there, 2v1, 2 into 32, and I1 is equal to 3 plus 20. So that becomes 64 minus 36 plus 20. So that's 48. So 3v2 is equal to 48. That means V2 equals to 16 volts. So we know all the unknowns are known now. This is 30 known now. This is 32 volts. V2 is equal to 16 volts, and I1 equals to 3 amps. These we know. We need to find the powers. Now when talking about powers, if for a source, if the current is getting, so this is plus minus, if the current was inwards, that means if I1 was negative, then we would say that the source is absorbing power. So that's not happening because the current is getting out of the source, from positive terminal it is getting out. That means the source is actually delivering power. So when it's delivering power, the power will be negative. That's how do it, because we know P is equal to VI, and for each one, so this is 50 volts, so V is 50 and I is 3, but we have to write negative because the current is getting, it's delivering power basically. So minus 150 watts. Similarly P 5 amps, if we do, so 50 volts, this is 5 amps. We know that we have seen that the polarity here, again the polarity here is like that, because V2 was here was V2 positive, and we have found the value to be positive. That means the source is also going in that, the source is delivering power in that direction, but that means this is also delivering, not absorbing. If polarity was other way around, or if the current source was in that direction, that would mean that this was dissipating. But now it's actually delivering, it is as well delivering. So this is also negative. It will be Vi, maybe I can write the negative later. Vi, I don't know, it's just the value has to be negative. So this is 5, I am writing first, and times the voltage is 16, so that's minus 80 watts. And let's last think about the independent source, sorry, dependent source. This is also polarity. Here was polarity 32 volts and this is 16 volts. So basically it was like this. So this was 32 volts, this was 16 volts. That means here the voltage drop is 16 volts. And the current here is of course 3I1, that means 9 amps. So for this one as well, the current is going in that direction, and while in the direction where current is going, the voltage is also rising. There is a voltage gain here. That means this is also delivering. There is no drop here. This is a voltage rise. That means this is also delivering power. So P3I1 we can write like that. That is Vi, and that will also be negative because this is also delivering power. So that's 16 times 9, which is minus 144 watts. So we have seen there are 3 power sources and they are all delivering powers.